Hello everyone. In this video, we are going to discuss program number 3, which is on thread management using Pthread library. Pthread library provides functions to create and manage threads. And in this program, we are going to use those functions to build an application to demonstrate the creation of threads. So before proceeding to the program, we need to understand a bit more about process and threads. So when a process is loaded into the memory, it has got these sections. So the text section, it contains the executable instructions of the process, basically the contents of a.out file. And then we have the data section. So the data section, it stores the global variables and static variables. So if you recall, the global variables and the static variables have a scope of a lifetime. That is, they exist until the execution of the program, right? So it has got a separate section for that. And as you know, the heap section, it is the region of memory from where the dynamic memories are located. And then we have a stack. So whenever a process makes a function call, the calling functions, local variables, return address, and the function parameters are pushed onto the stack. So this, we call it as a address space of a process. So the diagram which you have seen in the previous slide is a little bit modified here. So this is a process or a single threaded process. So here the code is nothing but the text section and the data section, and we have a stack section here. File is basically the input and output file that the process is associated with, and the registers are the registers that the process is using. For example, the program counter, ALU registers, and so on. So this is a process or a single threaded process. Suppose we have an application wherein we are required to execute multiple tasks. Basically, we create process or threads to execute some task, right? And we have an application wherein we are required to execute multiple task which is performing a similar code, which is performing a similar task, and it is using on a same data. Then instead of creating separate processes, we can create threads within the same address space. So as you can see here, we have created 3 threads within the same address space. So each of these thread is going to use the same code, and it's going to operate on the same data, and it's going to use the same files. Whereas as each thread is executing a different task, then that execution context is captured by its own stack and register variables. For example, we have a matrix, 90 cross 90 matrix, and suppose we want to find the sum of rows of sum of rows of that matrix. So what I can do is, so each thread is going to find the sum of row, right? So I'll create one thread to find the sum of rows from 0 to 30, right? So sum of rows, it's a common task, right? So and the matrix is also common between these threads. They are executing sum of row function, and the data is the same matrix. But this thread, it's going to compute the sum for rows 0 to 30, and this from 31 to 60, and this from 61 to 90. So in this way, instead of creating a single process or 3 processes, or we can create multiple threads within the same address space, and this is going to save memory as well as time, OS time for creating the threads. So next, let us discuss the functions that are used to create and manage threads. So these are the 3 important functions. So first one is pthread create. So this is used to create the threads, and the first argument is passed by reference, address of type pthread underscore t. When the thread is created, the operating system assigns a unique ID to the thread, and that is captured by this first argument. The second is address of type pthread underscore attr underscore t structure. So each thread has got a certain set of attributes which are initialized by the operating system when the thread is created. We can receive these attributes using the second argument. In our program, we are not using this attribute, thread attributes, hence we'll to simplify it, the second argument we are going to keep null. The third argument is a very important, as it's a function pointer here, as here you can see, and this is the function that the thread is going to execute, and the signature of this function is fixed, and you can see it takes the void star as an argument and it returns void star. You cannot change the signature of this function. And the third, so basically here you're going to pass the function name. It's a you're going to pass the function name here, and the fourth argument is the argument that you're going to pass to this function. So the third argument being the function name, and if you want to pass arguments to that function, that you're going to pass as our fourth argument here. So pthread underscore create function, it returns 0 on success and -1 on failure to create a thread. Then we have a pthread join function. So pthread join function calls the blocks the calling process until the thread with the which is given as a first argument is completed. So it blocks the calling thread until the thread which you have given as a first argument completes its execution, and the second argument is the return value from the completed thread. And similarly, it returns 0 on success, -1 on failure. And the pthread underscore exit terminates the calling thread, and the parameter that you're going to pass will be returned to the parent process. So let's now proceed to understand the program. So included the header files. I've included the most important is pthread underscore h. So I've included pthread underscore h library. And then I've declared int I variable as a global variable, and this is the value which is shared by all the threads. Next, line number 8 to 12 is the function that the threads are going to execute. So it's a simple function, print function, and it, as you can see, it is taking void star as an argument and returning void star as void star. Let's go to the main function and come back to this later. So in the main, I'm creating an array TID of type pthread underscore t. So this is basically to store the thread IDs. And now I'm using a for loop to create 3 threads. This for loop is going to run 3 times. Basically, in this for loop, I'm using pthread underscore create to create the threads. So the first argument, I'm passing the array TID, address of array TID. So each is going to capture the thread ID of the process. So TID of 0 will capture the thread ID of first thread, TID of 1 will capture the thread ID of the second thread, TID 2 will capture the thread ID of the third thread. And the second argument, if you recall, it was an attribute. So as we are not using it, I'm keeping it null. And the third argument, very important, each thread is going to execute print function here. And the argument that I'm passing here is address of type address of I variable I which we have declared is a global here, which is a for loop. So it's going to pass the so when thread 0 is created, it's going to pass value 0, and when 1 is created, it's going to pass 1, and so on. So now I'm calling sleep function here, sleep function, because as I'm passing I here, and the thread creation is so fast that we may miss out on the value of I that we are passing to the thread. Hence, in order to give certain gap between the creation of threads, I'm using sleep here. So basically each thread will be created, and then there's a pause of 1 seconds, and then the next thread will be created. And then pthread join. So in the for loop, I'm calling pthread join, and I'm passing the thread IDs. So basically this main thread will wait until it completes all the 3 threads. Look into the function. So print function. So it is receiving 0, 1, and 2, right? For thread 0 will receive 0, thread 1 will receive 1, and thread 2 will receive 2. So as it is void star type, it is receiving the address of I. I'm typecasting it to be of integer type, right? And then I'm printing here hi I'm thread, and I'm printing the value of j here. So basically there we are passing the address, and we are typecasting that address is of integer type. I is of integer type, right? But it is expecting void star, hence we are typecasting it to be void star, right? And whereas in the receiving function to in order to use it, we need to typecast it back to int star type. Hence the same thing we are doing here. We are typecasting it to int star, and here we are dereferencing the variable and printing its value. So let's execute this. So when executing pthread functions, we need to use this switch lp thread because it links the function with the pthread library. It is mandatory. Now the program is compiled. Let's execute. So you can see the 3 threads are created. Each thread is executing the same code but different values of I. Now let us see an application program using a matrix, so which we had discussed in the slides. So here you can see I'm creating a matrix. It's a global variable and hence common to all the threads. It's stored in data section, which is shared by the threads, if you recall. So I'm creating a variable, creating a matrix, 3x3 matrix, and I have initialized it. So I'm going to create one thread which to compute the sum of elements of first row, and the second thread to compute the sum of second row, and third thread to create the sum of third row. So the same code changed here. So the main function remains same, right? I'm passing the thread, right? I'm passing the thread number. So based on this number, it's going to find the sum of that particular row. It's going to find the sum of that particular row. So the print function, I have just modified a little here. I've declared a sum variable and initialized to 0, and the for loop variable declared, I have declared as m, and it's printing the same hi, I'm thread percentage d star j. So now I'm to find the sum of that particular row. To find the sum of that particular row, I'm taking m is equals to 0, m less than 3, m plus plus. Sum is equals to sum plus. So you can see it's taking the row number. So if it is thread 0, it will be 0, 1, 2, 3. A of 0, 1, A of 0, 2, A of 0, 3. Sorry, A of 0, 0, A of 0, 1, A of 0, 2. Right? If it is thread 1, then it will be A of 1, 0, A of 1, 1, A of 1, 2. If it is thread 2, it will be A of 2, 0, 2, 1, 2, 2. And after finding the sum, I'm just printing the sum of row percentage d is percentage d, and then I'm calling pthread underscore exec, which terminates the thread. Let's see its execution. So you can see now thread hi, I'm thread 0, and it's printing the sum of row 0, and thread 1 it's printing the sum of row 1, and thread 2 it's printing sum of row 2. So in this way you can create multiple threads within the same address space, which are sharing the same code and the data, and in this way you can save the time and memory. I hope you all understood this program. So I want each of you to pick up a different application which basically uses the common code and common data. Thank you.